We're now going to have a look at how we convert true course to compass course, which of course you would need to do when telling the helmsman what course to steer. So we're looking at converting true to compass. Of course, the first important thing you need to know is what corrections to apply, which are variation and deviation, and what sequence that you apply those corrections. And a little acronym would be useful, and I've written the letters here: TVMDC, which is true, variation, magnetic, deviation, compass, which is the sequence we must follow. So if we were to say that timid virgins make dull company, that will help us to remember the sequence that we use. So let's say in this example our true course is 244 degrees and we wish to convert that to a compass course. And from our chart we know that our variation is 3 degrees east. So we've got 3 degrees east. Now we need to calculate our magnetic course. Which way do we apply the 3 degrees east? Well, when we looked at compass to true, we used this acronym. So if we went from compass to true, we added east. So it would follow that if we were going from true to compass, the opposite, we will subtract east. So going from compass to true, add east. The opposite, true to compass, simply subtract east. So we now have a magnetic course of 241. 241 degrees magnetic. We need to calculate our compass course, therefore we need to find the deviation to apply to go from magnetic to compass. How do we do that? Okay, let's look at our deviation table. And on the deviation table here you can see that at the top we have ship's head by compass, then we have deviation, and I've written here that an application of deviation to the ship's head by compass will give us magnetic course. So if, for example, our ship's head was 100 degrees, our magnetic, applying the deviation of 12 degrees east, would give us 112 degrees. If we looked at 200 degrees, apply the 2 degrees west, that will give us 198 magnetic. Now the magnetic value that we have is 241. So what we need to do is find two magnetic values that fall either side of 241. That's to say, one magnetic value of less than 241 and one magnetic value of more than 241 to enable us to calculate the deviation. So let's look around the 200 mark. So at 200 degrees compass we have a deviation of 2 degrees west, so that would give us a magnetic value of 198. 220 compass, 5.5 degrees west is going to give us 4.5 degrees magnetic. We're looking for 241. 240 degrees compass, applying the 8 degrees west will give us 232 degrees magnetic. 260 compass, applying 10.5 degrees west will give us 249.5 degrees magnetic. We want 241. So as we can see here, the value of 241 magnetic falls between these two values. The compass values now have served their purpose. We don't need them anymore. So let's write down the values that we've got. We've got 232 degrees magnetic, 249.5 degrees magnetic, 232 magnetic, 249.5 magnetic. Let's write down the deviation values for those two. So at 232 magnetic, it's 8 west, 249.5 magnetic, it's 10.5 west. So let's write down those two values. 8 degrees west, 10.5 degrees west. So that's the deviation, and these are our magnetic headings. So now we've finished now with the deviation table. We've got our two values, and we also know our magnetic value here is 241 degrees. Again, looking at the values of deviation, by interpolation, we're going to end up with a value between 8 and 10.5 degrees. It must fall between those two because 241 degrees magnetic falls between 232 and 249.5. So let's see how we calculate the value. Let's get the difference between 232 and 249.5. That comes to 17.5 degrees. So the difference between 232 and 249.5 is 17.5. The difference between 8 degrees west and 10.5 degrees west is 2.5 degrees. We need to go from 232 degrees to 241. So 232 degrees to 241 degrees is a difference of 9 degrees. 232 to 241. So if we say that 9 degrees over 17.5 degrees is the part of the interpolation for magnetic, i.e. 232 to 241 is 9, 232 to 249.5, 17.5. So it's 9 over 17.5 multiplied by the difference of 2.5 degrees. Mathematically that comes to 1.3 degrees. So if we apply this value of 1.3 degrees to the deviation, we are going from 232 towards 249. So we're going from 8 degrees towards 10.5. So it would follow that we must add that value. This 1.3 degrees we must add to 8 degrees. So that will give us a deviation of 9.3 degrees west, because we've gone from 8 plus 1.3 is 9.3 degrees west. So we can write there 9.3 degrees west is our deviation. Now, we know that if we went from compass to true, we'd add east and subtract west. Of course, we're going from true to compass, so we do the opposite. So in this instance, we would of course add the west. So our compass course is 250.3 degrees compass. So if you remember, timid virgins make dull company. True, apply your variation, get your magnetic, go to the table indicating the deviation values, ship set by compass, work out your magnetic values. Get magnetic values either side of your magnetic value in your calculation. Once we've got them either side, we can now interpolate to find out what deviation to allow. In this problem, we calculated the difference was 1.3 degrees. We're going from 8 to 10.5. 8 plus 1.3, 9.3 degrees west. So our deviation is 9.3 west, giving a compass course of 250.3 degrees. And that's how we solve going from true to compass.